In today's video, let me explain about aromaticity in organic chemistry, in general organic chemistry. Aromatic compound, anti-aromatic compound, non-aromatic compound का cyclic compound से cyclic organic compound से we classify into three types. One is aromatic, another one is non-aromatic, and third one is anti-aromatic. Three types of cyclic compounds. Now stability order of these three compounds is aromatic is most stable and the anti-aromatic compounds are least stable. They are not stable at room temperature, they do not exist at room temperature. Okay, so stability order is first one is aromatic, and then non-aromatic, and last one is anti-aromatic. Okay, so how can we define aromatic compound or anti-aromatic compound or non-aromatic compound? So what we need to check is, first of all, we need to check whether the compound is cyclic or not. If this is cyclic, then we must check hybridization, whether all the atoms in the ring is sp2 hybridized or not. This is to be checked. If all the atoms are sp2 hybridized, then the compound may be aromatic or anti-aromatic, right? This is anti-aromatic. Now if this hybridization is, if one of the atoms in the ring is sp3 hybridized, then if any atom or all the atoms are sp3 hybridized, then the compound is non-aromatic. This is to be checked, right? So if the atoms in the ring are all sp2 hybridized, then the compound may be aromatic or anti-aromatic. So aromatic when there are 4n plus 2 pi electrons, the compound will be called aromatic, and if number of pi electrons is 4n, then the compound will be anti-aromatic. So here, what is n? N can be 0, 1, 2, 3, like this. So this is the way to how we can differentiate aromatic, anti-aromatic, and non-aromatic, or how we can know a given cyclic compound is aromatic, anti-aromatic, or non-aromatic, right? So let me give you some examples. First example is very simple example is benzene. This is benzene. So first of all, we need to check whether some compound is cyclic or not. This is a cyclic compound. So after this, we need to check hybridization of each atom in the ring. So in benzene, each atom is sp2 hybridized. Each atom is sp2 hybridized. This is sp2, this is sp2, right? Each atom in the ring is sp2 hybridized. So after this, we must count the number of pi electrons. here number of pi electrons is 6, right? So we need to equate this 6 with 4n plus 2, or we need to equate this 6 with 4n, and here n will be equal to 1. So n can be 0, 1, 2, 3. Sigi mayam sigi maraktane n gi value si oiraba amata ko adurgadi koina compound aromatic hydrogen ko 4n plus 2 pi electrons leiba haibse sai rule do sigi sibu koina Hakel's rule haiduna kaweba Hakel's rule ko Hakel's rule ko adugo 4n pi electrons leiragana ikoina anti-aromatic ni hydrogen sidagi n gi value se pudok mutam sigi masing si manung da ama taro oeba se tar habina ko say for example say the 6 by 4 ni have the 3 by 2 in lie. This is not one of these numbers, so anti-aromatic oil n is equal to 1 for n plus 2 pi electrons later in Hakel rule follow tawre, which means this benzene is aromatic. So many koina aromatic oil anti-aromatic oil have say koina khangbangang whenever. And this example that if this is a compound sigi coin check to ko cyclic ore each atom in the ring is sp2 hybridized csp2 ore ko adu orgadi hoji yeng se ko pi electrons masing thirasi pi electrons mari lere mari si hoji ai 4n plus 2 ga equate to ge ko Hakel's rule follow to yeng se ko sidagi n equate n calculate to matan to 1 by 2 la 1 by 2 cd si number si manung dam oibra oidi aduna takpadi hi se Hakel's rule follow to dre habadi si aromatic natre ko aduna ikoina force pi electrons masing force 4n ga equate to matam dadi n gi value si kya la 1 la si masing am la ko, which means si rule si anti-aromatic ni 4n sina anti-aromatic ni 4n plus 2 sina aromatic ne ba ko aduna sidagi n gi value the fraction la abnina aromatic oidre adugo 4n ga ujiki 4 siga equate to matam n gi value si one of this number lak panina sigi compound si kari tare dute this compound is anti-aromatic. Yare ko sa yan tarani ko ai mathang example lam lor kengo mathang example si ahum sab example se suppose if I take this compound sumaina say the cyclic ore hybridization yengani this is sp2 double bond leibni na ko this is sp2 but this carbon atom is sp3 hybridized. If one of the atoms in the ring is sp2 hybridized, then this compound becomes a non-aromatic compound yare ko adu zik makhata ba example kharam lo seng ko sigi compound si aromatic oigetra se double bond lere si ahum hairage ko si negative charge leiba aduga se positive charge leiba sigi ahum se dengo sigi hybridization sp3 ore aduna sigi si khoina kem check tawninga later this is non-aromatic yare ko now this is sp2 carbon anion si sp2 hybridized carbon atom amaga attached to bo orgadi mage so hybridization sp2 oi have rule ama lei ko aduna ma sp2 hybridized ore carbocations are always sp2 hybridized. This is sp2 hybridized, this is sp2 aduna hoji khona ani sta yengador si kaino si ani si non aromatic di oidre ko either aromatic natragana anti aromatic ore aduna si case ti yenga se ko si case da hoji pi electrons masing thire si ani leire ko ani si khoina equate to ba kanaga 4n plus 2 ga equate to se ko is equal to 2 ado sidagi n gi value si 2 ni ko sidagi n gi value kya la 0 si somse 0 tare ko n gi value si 0 tare ang za ha give the n gi value si kari go bi ai ba 0 ꯑꯣꯏꯕ ꯌꯥꯏ 1 ꯑꯣꯏꯕ ꯌꯥꯏ 2 ꯑꯣꯏꯕ ꯌꯥꯏ 3 ꯑꯣꯏꯕ ꯌꯥꯏ ꯁꯨꯃꯥꯏꯅ ꯂꯩꯌꯦꯕꯀꯣ 0 ꯑꯣꯏꯕ ꯌꯥꯏ n ꯒꯤ ꯚꯦꯂꯨꯁꯦ ꯑꯗꯨꯅ ꯁꯤ Haeckel's rule follow ꯇꯧꯔꯦ which means this compound is aromatic. This compound is aromatic. Now let us check this compound. Sigi anion se sidaida pi electrons masing thirasebako sigi electron ani si pi electron laire sigi negative charge the electron ani leirinebako sigi electron ni si uchi resonance participate tawba ngambra answer is yes ngami aduga di sigi electron ani su pi electron count tawbudi yawganeba aduna sigi system sida pi electrons kya yawre mari yawre aduna mari si khoina 4n ga equate taw matamda 4n ga equate taw matamda n gi value si 1 ina lae ko one of this number lae aduna takati 4n di anti-aromatic ni ko aduna sigi anion se cyclic anion se ko sigi compound si kari tare this is anti-aromatic yare ko sima sumaina khoina identify tawdaba ko aduna sigi ahum sida this is non-aromatic, this is aromatic, and this the middle one is anti-aromatic. And ahum sida stability order high hargadi sigi ahum subisna quite stable organi because this compound is aromatic mathang da ahan basi lakani aduga aroi bada sigi si laane ko yare ko sima next hojik manga sub example ama sum lor ke yam ko suppose sumaina si 5 member ring gi ay musik sumaina lawrage ba ko so double one simedi high na sa csp 3 hybridized or aduna ma si non-aromatic way ko let me take carbocation here sumaina aduga sugumba ama sub manaba I carbon am lawge ba ko sumaina so double bond say the post negative charge the lone pair ma yawrni always sikaw ya de ko aduna sida hojik masing thire se pi electrons masing thire se pi electrons masing thiba matamda ingo sida pi si sp2 hybridized loan orni carbocation se always sp2 hybridized oibni ko carbon su sp2 hybridized ka dash tawdina this is also sp2 hybridized aduna all members all atoms in the ring is sp2 are sp2 here also all the atoms in this ring are sp2 hybridized therefore we need to count number of pi electrons here in this system 4 pi electrons so this will be 4n is equal to 4 n give value will be 1 so this compound is anti-aromatic okay anti-aromatic okay now what about this so pi electrons masing 0 ama ani ahum mari manga taruk 6 pi electrons are here 6 say 4n plus 2 ga equate to matamda n gi value comes out to be 1 so one of these numbers so Haeckel's rule follow tawre this compound is aromatic this compound is aromatic there you go okay let me go through some other examples next example is this one this is pyrrole nitrogen has a lone pair of electron here right and next one is this is furan this is pyrrole this is furan and another one similar compound is this is double bond okay this double bond this is just similar to this furan this is called thiophene this compound is called thiophene as a trick remember this all these three compounds and the one is there this one this is called pyridine okay all these 4 compounds are aromatic let me explain why in this case okay in this case these are all sp2 hybridized because n has a lone pair of electron if an atom has a lone pair of electron and if it is attached to an sp2 hybridized carbon atom this is also sp2 hybridized similarly this is also sp2 hybridized, oxygen is sp2 hybridized in this case, sulfur is sp2 hybridized in this case, right? So we need to count number of pi electrons here, 1 2 3 4, and whether these 2 electrons will be counted as pi electrons or not, this will be dependent upon whether these electrons can participate in resonance or not. Obviously these 2 electrons can participate in resonance, therefore these 2 electrons will be counted as pi electrons. So in pyrrole there are 6 pi electrons, so in 4n plus 2, number of pi electrons will be, when n is equal to 0, 2, when n is equal to 1, this is 6, when n is equal to 2, this will be 10, like this, right? 14, like this. So if the number of pi electrons is either of these numbers, then the system or the compound or ion will follow Ackel's rule, means the compound will be aromatic, right? And if it is 4n, then this will be 0, right? And this will be n is equal to 1 means 4, n is equal to 2 means 8, n is equal to 3 means 12, and if number of pi electrons are either of these numbers, then the compound will be anti-aromatic, the compound will be anti-aromatic, right? So this has 6 pi electrons, means pyrrole is aromatic. Similarly furan, in case of furan, there are 2 lone pair of electrons. Between these 2 lone pairs of electron, only one lone pair of electron will participate in resonance, so these 2 will be counted as pi electrons, but these 2 electrons which will not participate in resonance, they will not be counted as pi electrons. Pi electrons are those electrons which are present in p orbitals. These 2 electrons out of the 4 electrons will present in p orbital, therefore only 2 electrons will be counted as pi electrons, right? So here also, how many pi electrons? 1 2 3 4 5 6. These 2 electrons will not be pi electrons, right? So 6 pi electrons will be there, therefore furan is also aromatic. Similarly thiophene is also aromatic. In case of pyridine, these are all pi electrons, 6 pi electrons is there, but nitrogen has a lone pair of electron. This lone pair of electron is present in sp2 hybrid orbital, and those electrons which are present in hybrid orbital, they are not counted as pi electrons. So only 6 electrons will be pi electrons in this case. So 6 pi electrons means aromatic. So pyridine, pyrrole, furan and thiophene, all these 4 cyclic compounds will be aromatic compounds, right? Okay, let me go to another example, last set of examples. Here if I say this compound, this is naphthalene, this is naphthalene, right? Naphthalene is aromatic or not? Let us check whether this is aromatic or not. On the lastly, I am taking another example, whether this is aromatic or not. This and okay, now let me check let me change the color of the pen. Okay, here all the atoms in the ring are sp2 hybridized, so we need to count number of pi electrons. Naphthalene has how many pi electrons? 10 pi electrons. 10 pi electrons means naphthalene is aromatic. I have already told that if the number of pi electrons is 2 4 6 10 14, then the compound will be aromatic. So naphthalene is an aromatic compound. Let us check this compound. This is sp2 hybridized carbocation. This carbanion is also sp2 hybridized because this is attached to an sp2 hybridized carbon atom. So this will be sp2 hybridized, this will be sp2 hybridized. All the atoms in this ring are all sp2 hybridized. So let us count pi electrons: 2, 3, 4, and this carbanion contains 2 electrons. This has no electron. So this, whether these 2 electrons which are lone pair, whether these will be counted as pi electrons or not, will be dependent on whether this can participate in resonance or not. This can participate in resonance, so these 2 electrons will be counted as pi electrons. So how many pi electrons will be here in this species? 6 pi electrons, which means this compound or this ion will be aromatic. Okay, for today let me complete this video here. In the next video of aromatic, I'll come with another examples, some complex examples to check aromatic or not. Okay, please share this video, and if you are new to the channel, please subscribe to the channel and also press the notification button, so that whenever I upload a new video, you get it immediately. Thank you.